Okay, so what we have here is I've found the acceleration of a block initially traveling up an incline and then coming back downwards. And over here I calculated its velocity going up, and you can see in my diagram that I have the force of friction going. Well, actually, let me start over. I have my x and y coordinates are right here like this, and I have theta right there. And so I have the force of friction going that way and towards the positive x direction, and the force of its weight going straight down, and the normal force going parallel to the y direction. And I've divided up the force of the weight into the x and y components using sine and cosine. So right here we have sum of the forces in the x direction is the force of friction plus force of the weight times sine of theta equals mass times acceleration. And sum of the forces in the y direction would be the normal force minus the force of the weight times cosine of theta, which equals mass times acceleration, which equals 0. This shouldn't be ay, it should just be regular a, because these two accelerations are the same. Oh, I'm sorry, they're not this. It should be y like that, but they're not the same. But this one equals 0. So this whole thing, there is no acceleration in the y direction. That's why it equals 0. So using just this sum of the forces in the x direction, we divide by the mass and we get acceleration equals force of friction plus the force of the weight times sine of theta over its mass. Over here we have the same thing. I've calculated it going down. We have the same coordinate system and the same hill, but it's at the top of the hill on the way down this time. Same thing, we have the normal force perpendicular to the incline, force of the weight straight down, and I've divided up the force of the weight into the x and y components using sine and cosine. And this time force of friction is going that way, and I'm calling it negative because it's applying the force in the negative direction. So the sum of the forces in the x direction equals force of the weight times sine of theta minus the force of friction equals mass times acceleration. And sum of the forces in the y direction equals normal force minus force of weight times cosine of theta equals mass times acceleration, which equals 0 because there is no acceleration in the y direction again. And so using just this equation, we divide by m and we get acceleration equals force of weight times sine of theta minus the force of friction over mass.